Well, hi everybody. We're going to work this afternoon on balancing chemical equations. In order to balance an equation, you're going to have to be good at counting atoms in molecules. So I want to review that with you first. Now let's take a look at these three notations. I want you to think about how many molecules are represented in each notation. Now I've drawn a picture of each one of them to help you with this. So once you kind of have picked some answers out, we'll see what they really look like. Okay, here we go. In the first one, you see that the notation is Cl2. And what that means is that there are two chlorine atoms, and that makes one molecule. When you look at this middle one, it's written with a coefficient of 2 Cl's. So that's actually two chlorine atoms together, just in a beaker or a test tube. And then finally this one, 2 Cl2s, represents two chlorine molecules. Chlorine's a diatomic element, remember, so here's one of the molecules with two chlorines, and here's the second molecule with two chlorines. Make sure you keep in mind how to count the atoms as we learn to balance. Now, why are we balancing? Well, matter can't be created or destroyed, and we know that equations have to be balanced to account for that. And what that means in terms of working through an equation is that, let's say you start with 4 oxygen atoms on the left side of your equation, you have to have 4 oxygen atoms on the right side as well. The atoms must be equal on each side of the equation. And that's how we're going to balance, is by counting atoms, not molecules or charges or anything else like that. We're going to use the coefficients to balance our equations. Now there are two ways to balance. You can balance by inspection. Okay, and that's the first example that I have here. I've got the magnesium and the oxygen reacting together. And if you take a look here, let me switch to the pen that we have. I'm going to count magnesium on the left. I have 1 of those. Oxygens on the left, or the green circles, I have 2 of those. Then the product that I get, this is a synthesis reaction, it's magnesium plus oxygen. So I have 1 magnesium and 1 oxygen. Now, to balance that by inspection, I'm going to start to compare the magnesiums. I have 1 on the left side and 1 on the right side. So the magnesium's balanced, but the oxygen is not. You see how I have 2 green oxygen atoms on the left side here, but only 1 on the right? So in order to balance this equation, what I'm going to have to do is to add another green oxygen over here. Okay, and that's what I'm doing here with this coefficient. This coefficient gives me 2 MgOs. So when I do that, I end up with, let's go back to mouse mode here, I end up adding a second oxygen on the right side of the equation. And if I do that, that's fine, but I can't add that oxygen without the magnesium. So I've added a second magnesium on the right. That's a new, another one of those compounds. So now I have 2 magnesium oxides here, 2 green oxygens and 2 red magnesiums. Well, because I have balanced the oxygens now, the magnesiums are off. So I've also gone over here and added 1 more magnesium. You can see I've indicated that with that coefficient of 2. That is that atom down there. The coefficient of 2 here represents this molecule here. So now when you look at it, I have 2 magnesium atoms on the left and 2 magnesiums on the right. That's balanced. And with the oxygens, I have 2 green oxygen atoms on the left, and I have 2 green oxygen atoms on the right. So by putting these coefficients in front of those formulas, I now have a good balanced equation. Alright, let's look at another one. Now in this practice problem, I've already drawn out kind of the skeleton molecules for you. We have P4, which is 4 phosphorus atoms, and they are here. The 4th one, I believe, is hiding under this this writing toolbar. Then I have 2 oxygens located there, and then my product is P4O10. So I have 4 blue phosphorus atoms and 10 red oxygen atoms. Now if I'm going to balance this, let's do it by inspection. I have 4 blues and 4 blues, so the phosphorus is balanced. But what's not balanced is the oxygen. I have 2 on the left side and 10 on the right side. Now you need to think about this in terms of multiplication. What can you multiply by on the left side to give you a total of 10 oxygens on the right? If you were thinking 5, then you'd be correct. So if we take a look, what I've done is brought in this coefficient of 5. That allows me to have 4 phosphorus atoms here and 4 here, so those are balanced. Now I take this 5 and I multiply it by the 2, so 5 times 2 is 10 oxygens on the left side, and look here on the right, I have 10 oxygens there as well. So this now is a good balanced equation. The coefficient of 5 in front of that oxygen did the job for us. There's another way to balance equations, and that's called the inventory method. This is actually the method that I prefer while you're learning to balance. In this method, what you're going to do is count everything and take an inventory of it on your paper. So I want you to set up a little chart like this. We're going to look at the number of each element on the left side of the equation and each element on the right side of the equation. So I've just made a list: magnesium, hydrogen, and chlorine on the left side, and then magnesium, chlorine, and hydrogen on the right side. So let's go through and do that inventory. On the left side, if I count the magnesiums, I see 1. I have 1 hydrogen and 1 chlorine, only on the left side of the equation where the reactants are. Now over on the right hand side of the equation, I have 1 magnesium, I have 2 chlorines, and I have 2 hydrogens, because remember, hydrogen's diatomic. So there's my inventory to begin with. You can see by looking at the hydrogens and the chlorines that this equation is not balanced yet. So what I'm going to have to do is figure out what to multiply the left side by, because that's the smaller number. What do I multiply these 1's by to give me 2 on the right hand side of the equation? Now it doesn't matter which element you balance first. I'm going to start with the hydrogen. I think what I need to do is multiply hydrogen by 2, because 1 times 2 is 2. I'm going to do that by putting a coefficient of 2 right here in front of that hydrogen. Coefficients may not go in the middle of a formula, so you have to put it in front. Now when I do that, that's going to give me 2 hydrogens, so I'm just going to change the inventory here, and look, it balanced the hydrogen. But this 2 also affects the chlorine that's here. So now I have 2 chlorines. And just like that, this equation is now balanced, because I have 1 magnesium on both sides of the equation, and I have 2 hydrogens and 2 chlorines on each side of the equation. So the coefficients that balance this reaction are 1, it's understood, 2, 1, 1. And that's how you do the atom inventory method. Now you have plenty of equations in your packet to balance for practice using either method, so I encourage you to give some of them a try, and I'll help you in class next time. Thanks!